Hi, we're back. We're still on Chapter 9, Developing Basic Fact Fluency. We are on reasoning strategies for subtraction. Subtraction facts prove to be more difficult than addition facts for our students. Perhaps because it receives less attention and because it requires knowing the related addition facts. So imagine the double whammy. So I haven't mastered my addition facts, and now we're moving into subtraction, where we're going to spend less time, and I'm going to depend heavily on my addition facts, which I haven't mastered. Without opportunities to learn and practice reasoning strategies, students continue to rely on counting strategies for subtraction, which is a slow and often inaccurate approach. A lot of times students will get an answer wrong because they're counting on. They lose track. Counting on is great for small numbers, but when you get over 10 or 20, or the numbers of the amount of fingers and toes you have, then counting on can become a problem. Therefore, make sure that you spend sufficient time working on reasoning strategies for subtraction to help students move to phase 2, which is the reasoning strategy stage. So you want them to move from counting on to reason strategy, and then eventually to mastery or automaticity, where they just know those answers like that. They know those facts like that. So what are some reasoning strategies for subtraction? Well, we first have think addition. Wow. So if I haven't mastered my addition facts, one of my subtraction strategies is think addition. And they give an example of 13 minus 8. You can think addition and say 8 plus what number gives you 13. That is the thinking on think addition. We also have down under 10. The down under 10 is the reverse of making 10. And there are two ways that you can look at it. You can look at it as separate, or you can look at it as compare. For example, the problem 14 minus 8. For separate, you are taking away 8. So jump down 4. So we're taking away 8. Jump down 4. Then jump down 4 more. Jump down under 10. The answer is 6. Or you can say, how far from 14 is 8? 13, 12, 11, 10, 9, 8. 1, 2, 3, 4, 5, 6. These are the down under 10 strategies. And then we have take from 10. This is an excellent strategy that is not well known or commonly used here in the United States. So you have the problem 15 minus 8, and you want to take from 10. So you want to say, you want to just kind of put this 8 here, and you want to do this 15, 10 plus 5. Then you want to take from 10. So you want to take, you've got this 10, and you want to take this 8 from it, and that gives you 2. You still have this 5 that you need to add back to the 2, which gives you 7. Wow, Dr. Brooks, can you work that again? Sure. Let's try it with another one. Let's try it with 12 minus 8. Again, I want to take from 10. So I want to have a 10 somewhere. Where can I get a 10? Here. 10 plus 2. So I'm going to just pocket the 2. I'm going to do 10 minus 8 equals 2. I'm going to take the 2 back out my pocket, put it to the 2 that I had left over. The answer is 4. Again, it's not about what you're comfortable with. All you need to be comfortable with is that the research says this, that countries that are doing math correctly do it like this. And then you need to be confident when you present it to your students and make sure that you're accurate. But you want to provide them all of the strategies, reasoning strategies for subtraction so that they can pick the one that works best for them. And again, they might not use the same one every time, and different situations may warrant different strategies, but they need to have the strategies, because what we can't do is teach students who are already struggling, especially, but all students, we can't teach them 100 addition facts, 100 subtraction facts, 100 multiplication facts, 100 division facts. We can't expect them to memorize 400 facts and then be really effective in math. Then we have reasoning strategies for multiplication and division. This is on begins on page 199. We have our foundational facts. A good place to begin multiplication facts is with the 2s, the 5s, and the 10s. These facts connect to students' experiences with skip counting and addition doubles. Tens are not basic facts because 10 is 2 digits, but it's listed here because of skip counting and this being a natural progression. We also can't forget about zeros and ones. They are foundational facts. Those zero facts do not help generate other facts, but we have to make sure that the students understand this, not just generalize it or memorize it. So we want them to understand how come 10 times 0 equals 0. We talked about that last week in class. We have 10 baskets with nothing in each basket. And when you give those story problems and you bend it in real world experiences and examples, it can help the students to understand 0. Remember, we talked about one of our first class meetings was talking about this concept of 0 and how the students struggle with 0. And then we have division facts. Oh, I'm sorry. So we want to learn our 2s, our 5s, our 10s, 0s, and 1s. And then we want to make sure that we talk about oh, and don't forget about the 9s. So we want to spend some time. The 9s are in a category by themselves. They are used for deriving the other facts, but there are several reasonings, strategies, and patterns specific to 9s. You have to excuse me because unfortunately, just like the rest of you, I am not home alone. So I have visitors who, of course, as soon as you start recording, want to come in and visit with you. All right. Derived multiplication fact strategies. You want to help students come up with some strategies for attacking their math facts. So one of those strategies is adding or subtracting groups. This strategy can generate many other facts. For example, all 3's facts can be thought of as something times 2 and 1 more. All 6 facts can be thought of as something times 5 and 1 more. As described earlier, all 9's can generate as times 10 plus 1 more. You can see an example of this on figure 913, which is on page 203. We also want to spend time on teaching doubles and halves, doubling and halving. Doubling applies the times two foundation and is very effective reasoning strategy in helping students learn the difficult facts. The double and the double again strategy shown on figure 9.14 is applicable to all facts with 4 as one of its factors. Remind students that the idea works when 4 is a second factor as well as when it is the first factor. Double and double again. So the fact is 4 times 6. Double and double again is doubling 6 plus 6. And then 6 plus 6 again. Double 6 is 12. Double again is 24. Double and one more set. When I have 3 times 7, I could double 7 plus 7 equals 14. 14 plus one more 7 is 21. Oh, we can do half, then double. So in the problem 8 times 6, we could do 8 3 times equals 24. And then 8 3 times again is 24. And the double is 48. Different strategies for attacking problems. Doubling, and then we have breaking apart. Breaking apart would be 7 times 7, where we are going to do 5 times 7 plus 2 times 7, which is going to give me 35 plus 14, which is going to give me 49. There are other examples too. And then division facts. Mastery of multiplication facts and connections between multiplication and division are key elements of division fact mastery. For example, to solve 36 divided by 4, we tend to think 4 times what is 36? In fact, because of this, the reasoning facts for division are to first think multiplication and then apply multiplication reasoning facts as needed. Missing factor stories can assist in making this connection. You can say Anna is creating a bag of mini muffins for a bake sale. She puts 4 in a bag and fills up bags until she has all 36 muffins in bags. How many bags did she fill? Notice this story can be represented as 4 times something equals 36, missing factor, or it can be looked at as 36 divided by 4 equals what? A division problem. Beyond division facts, students benefit from practicing near division facts. 50 divided by 6. Because near division situations are likely to happen in real life, requiring for estimating and requiring for solving larger division problems. To determine the answer of 50 divided by 6, students employ a guess and check strategy. 6 times 7 is too low. 6 times 8 is 42, but 6 times 8 is 48. Within 2, that must be it. Students should be able to do this near fact problems mentally and efficiently. So, looking at near facts can help you solve challenging problems, help students solve challenging problems mentally and efficiently. Reinforcing basic fact mastery. When students just know a fact or can apply a reasoning strategy so fast they almost don't realize that they've done it, they have reached phase 3, mastery. The Common Core Standards uses the phrase know from memory. Repeated experience with reasoning strategies are effective in committing facts to memory. Memorization is not. Therefore, games or activities that focus on reasoning strategies are more effective than drilling with flashcards and are more palatable for students. Students would much rather play a game than to do your old dry flashcards, even if you turn the dry flashcards into a game. Well, I am rewarded with a candy or never get a candy because I never get my facts right. Students must be fluent in basic facts, as students who continue to struggle with facts often fail to understand higher mathematical concepts. So when students lack basic fact fluency, mastery, they are going to struggle later on in life. Games are a fun way to play and practice something over and over again. They can help students learn and it can help them practice reasoning strategies. There are lots of games and activities in the chapter. Drilling is not effective. Drill, which is the repetitive non-problem based activity. It's not embedded in words. It's just, here's your problem, let's see if we can solve it, where the absence of reasoning has repeatedly been demonstrated as ineffective. However, drills can strengthen memory and retrieval capabilities. Drill is only appropriate after students know strategies and have moved from phase 2 to phase 3. So once you know that your students have mastered, so they've moved from counting on to reasoning strategies, so you've taught them their strategies. They are able now to articulate which strategies. You can see them picking a strategy, using a strategy, and then they're able to apply a strategy to come up with the correct answer time and time again. Now you can use drilling. But too often drilling includes way too many facts too quickly. Students become frustrated and overwhelmed. Also, students progress at different paces. So gifted students tend to be good at memorizing, while students with intellectual disabilities have difficulty memorizing. You can shatter their self-esteem and really crush that. There are a lot of sites where you can practice drill that makes it kind of engaging. And the 2 sites that they recommend is funforthebrain.com. Funforthebrain.com and mathfactcafe.com. Highly recommend it. Because they don't they let you, I assume what it's saying is that they let you pick fact families so that you are intentional with your drill. Fact remediation. Students who have not mastered their addition facts by 3rd grade or their multiplication facts by 4th grade or beyond are in need of intervention that will help them Master the facts. More drill is not intervention. Students who do not know their facts may be stuck back in the counting strategy, which is phase 1, and likely lack number sense and reasoning strategies, phase 2. Therefore, they'll never hit mastery, phase 3. Use these ideas to help students master all their facts. Explicitly teach reasoning strategies. I talked about that earlier. We often jump on teachers because they want to see you using a specific strategy. And I think if they articulated it like that, it would be easier for us and parents as well as everybody to understand that they would say, listen, we are mastering a particular strategy, and that's why I have to see here is a student work the problem like this. Once we've learned all of the strategies, then your child will be able to use the strategy that they think is most effective. But first, we as teachers need to teach them all of the strategies, even if we find it a little cumbersome. During this unit, yes, I did find, especially the one where, let me go back and look, the taking from 10, no, yeah, the taking from 10 probably was kind of a little left-handed for me, as in I'm right-handed, and that was a little struggle for me. All right, and we're on page 208, where we talk about the common challenges and misconceptions related to basic fact fluency. You have a student who does not recognize the inverse relationship. What does that look like? That's a student who doesn't know that this use triangle or T cards explicitly practice language used here. Students not able to think of what plus this, they can't think like this. And so you need to spend time teaching fact families, making sure that you're using the correct terminology. That's very important. Students do not apply the commutative property. Student is slower to add 2 plus 8. So they can do this all day long. They know that that's 10, but when you show them this, they pause. You can use 10 frames here and reverse them to help them see that these are both 10. So you can use your 10 frames. How many more do I need? Same thing, I can do it the other way around. How many more do I need? Both is 10. So spending time, that is one of the key problems with effective mathematics instruction. Spending time, giving the students an opportunity to build those reasoning skills, giving the student an opportunity to use the reasoning skills and to allow them to naturally progress through the steps. But first, us as the classroom teacher need to recognize that there are 3 steps when it comes to building fact fluency. 1, counting on. 2, reasoning strategies. And then 3, mastery or automaticity. That means that I can tell you that 8 plus 6 is 14 all day, every day. Hopefully I said that right. What to do when teaching basic facts. Ask students to self-monitor. Focus on self-improvement. Help students to want to learn those facts. Work on facts over time. Don't rush. Carve out a part of your day, recess time, bus time, lunch time, when you can spend time reviewing these facts and going over these facts and applying the strategies. Involve families. Find a way to send this home. Create a game. Help your students make a game. And their homework tonight is to go home and play the game with their parents. Parents would enjoy that. Students would enjoy that. You'd see much more interaction at home, and then you would get home helping you to buy in. Make fact practice enjoyable. If you're going to do drill, we shared 2 great websites with you. Find a way to make it palatable, manageable, and interesting for your students. Use some technology if that's what it'll take, and emphasize the importance of knowing their facts and explain why, and give them some scenarios. when I taught disabled students, I helped them to understand why it was important to use their math facts, because I would give candy and I would cheat them if they cheated themselves. And they quickly learned how to give the accurate answer so that they could get the correct amount of candy back. You can do that with your older students and play money, and if they have a certain amount of money left, they can make a purchase of maybe one of the like school bucks or a pencil or something like that, and you can help them by not cheating them, but by if giving them the incorrect change if that's what they tell you is supposed to be there. What not to do when teaching basic facts: don't use time tests. You're building anxiety in the students. Don't use public comparisons of mastery. Oh, remember that? There was a chart in the back of the door in your sixth grade classroom, and she was coloring in who was mastering their facts quicker. And if you were Lisa or Trinity, your chart was all, your line was almost completely colored in. But if you were Shonda, DJ, or Melvin, your line was not filling in as quick as theirs. It was really damning to our self-esteem as students. And one of us is dead, one of us is in jail, and one of us is a doctor. Um, Despite that, so don't put that chart back there behind your doors like that. Don't compare your students to one another. Don't proceed through facts in order from 0 to 9. We don't get facts like that. We don't get facts. Here's the first fact: 2 times 2, okay? And then the next situation that comes along, 3 times 7, and then the next situation is 4. Mix those facts up. Don't work all facts all at once. Pick a strategy. There are actually only 36 basic multiplication facts. Did you know that? There are 36 weeks in the year. So you could actually take a fact a week. And well, Dr. Brooks, how are there only 36 facts? And I'll show you. Got some more paper, killing a bunch of trees. And I'll show you exactly what I mean. Why are there only 36 facts? Because 3 times 2 and 2 times 3 are the same fact. So when I'm writing my facts, remember you stop at 9. When I start with my 3s, I don't need to do 3 times 2 because I already have it. So I can start with 3. And then when I do 4, I don't need to do 3 times 4. I already have it. I can do 4, 5, and so on. And it will equal out to 36 facts, which is much more manageable. Okay. Don't expect automaticity too soon. We've been on multiplication 2 weeks. These kids don't know these 36 facts yet. Don't expect it too soon. Remember, it's a process. You're working through phases and stages, and that is not going to happen overnight. The students must progress naturally from counting on to reasoning strategies to mastery or automaticity. Automaticity is I can give you the right answer in 3 seconds every time. And don't use facts as a barrier to good math. Mathematics is not solely about computation. Mathematics is about reasoning, using patterns, and making sense of things. Mathematics is problem solving. There is no reason that a student who has not yet mastered all basic facts should be excluded from real mathematical experience. Allow calculators so that students don't get bogged down on computation while working on more complex tasks. And lastly, don't use fact mastery as a prerequisite for calculator use. You can't use the calculator till you know how to multiply. Well, let me tell you a secret, Karen. If I knew how to multiply, I would need the calculator. But I'm getting problems wrong because I don't know a basic fact, not because I don't know how to solve the problem. And that's why calculator use is good in some instances, because a student may know how to solve the problem, just can't complete the algorithm to solve the problem. And so you don't want to see a student who is failing and they know the math, they just don't know the algorithm. So make sure that you know the difference between the two of those things right there, and that mastery is not a prerequisite for the calculator use. So they don't need to master it before they use the calculator. That brings us to the close of chapter 9. There will be a short quiz just to make sure that you didn't put this video on and then go clean your kitchen. You wouldn't dare do that, would you? Thank you very much. You have a good evening. This was EDCI 349, the book Elementary and Middle School Mathematics, Teaching Developmentally, Chapter 9, Whole Numbers.